In this video, we're going to go over problems that deal with the fundamental counting principle as well as permutations and combinations. So in this problem, we're talking about Minnesota passenger car license plates. We're told that the plates are in the pattern of 3 numbers followed by 3 letters, and we can use any number, but the letters I, O, and Q are never used. And in our first case, numbers and letters can repeat. So we've got 3 spots for numbers. We've got 10 options, 0 through 9. And we've got 3 spots for letters. Normally we have 26 letters, but we're going to subtract the 3 that aren't allowed. So we have 23 options for each spot. And we're going to multiply out those numbers. So now I'll pull up my calculator. And let's see. 10, well, that's to the 3rd power, right? Times 23, also to the 3rd power. And there's our answer, 12,167,000 different license plates that can be made. The next question asks us, well, how many in part A repeat no letters or numbers? So in that case, my first still has 10 options, but I only have 9 for the second and 8 for the 3rd spot as I use up numbers. Letters, I still have 23 available here. Once I use that up, I'm down to 22 and 21. So go to my calculator. 10 times 9 times 8 times 23 times 22 times 21 gives me, let's see, it looks like 7,650,000. Was that 720? Yeah, 720. All right, so almost cut in half, not quite. All right, in this next problem, we're talking about a school newspaper staff. We're told there's 6 boys and 10 girls. We're asked how many ways could 4 be chosen to a journalism conference. When I see the word chosen and I'm just grabbing 4 of them, I realize order does not matter. So this is a combinations problem. And in this first question, it doesn't matter if it's boys or girls. So it's just going to be 16 total kids. We're choosing 4 of them. So go into our calculator, and we've got 16 choosing 4 of them for 1,820 options. And the next question we're asked, how could we choose them so that they're all boys? Well, there are only 6 boys, so we're going to choose our 4 from that. And we go back to our calculator and we do 6 math. There we go. Over to probability, choose combinations again. 64 gives us 15 ways to have 4 that are all boys. Now, what if we want to have 2 boys and 2 girls attend the conference? Well, first we have to choose the 2 boys from the 6 total, and then we have to choose the 2 girls from the 10 total, and then to find all the different combinations, we multiply those 2 numbers. So we're going to have 6 math, go over to our combinations, 2, so that's 15 ways. And then, by the way, it shouldn't surprise us that that's the same as over here, because when we had 6C4 equals 15, for every 4 boys that were chosen, 2 were not. Well, this is the opposite. If we had choose 2, there are 4 not chosen. So that's why that number is the same. 6C2 and 6C4. Think in Pascal's triangle, you have the symmetry on the 2 sides. You're going to have 15 for both of those. All right, let's grab 10. Oops, there we go. 10. Math. C2. And this time we have 45. And now all we have to do is multiply 45 times 15 for a total of 675 different ways we could have 2 boys and 2 girls. All right, in our last question, we're working with a librarian. They have 12 new books. She wants to display 5 of them on the top shelf. How many ways could she display all 12 on the top? Well, the first spot would be 12, then 11 times 10, and as we multiply all those, we're going to be getting 12 factorial is the number of ways she could display all of them. And this question, let's see, in how many orders? Notice the word orders was there, so that would tell us that order matters. So here we go. We've got 12. Again, we go to the math menu, over to probability. Choice 4 is our factorial. And wow, that's a lot. 479,001,600. So 479,100,000. I think that was the number. Oh, no, I have the 1 in the wrong place. 001. Let's fix that up. All right, our next question says she only has room to display 5 of the 12 books. How many ways can she choose which 5 to display? This is a combinations problem. Choose doesn't have to do with order. So now we're going to do 12C5. So we go back over here. We've got 12 and math. We go over here, choice 3, 5, 12C5. We've got 792 ways that she can choose which 5 to display. Now she's got to figure out how many ways could she arrange 5 of the 12 books. So if we care about order, arrange means that order matters. That's going to be 12P5. And so we go back in here, 12 math, go over here, P5. And there's our answer, 95,040. So you can see how different your answer is when order matters.